Welcome to this second video in our series on data flow diagrams. In this video, we are going to learn about the symbols that we use in data flow diagramming, as well as the rules around how to use those symbols to create a meaningful data flow diagram. Now, remember, the business processes, and I have a business process shown here that we ended our last video with, and this is a representation of the process of placing a pizza order, as well as the inputs required to be able to perform that process, as well as the outputs that are produced as a result of that process. And so I've placed the process front and center here because, again, business processes are the main character, the star, the heart of data flow diagrams. In fact, that's what we're trying to represent through the process of data flow diagramming. Now, placing a pizza order is one of multiple processes in, let's say, a pizza ordering system. What we don't capture here yet is where the inputs come from and where the outputs go. So let's take a look at the receipt data and the order data that we have for to and from the placing a pizza order process. So the order data originates from customer, and the receipt information is outputted to customer. And so customer is what we call an actor or an external entity. It's not part of a process, but rather it is the originator of data, and it is the ultimate destination for the information that's produced from a process. Net profit that we see at the top, well, we're going to store this information. And so what I've represented here is what we call a data store, and I've labeled it finances to simply represent the idea that we store financial data. We also store menu item data, and that's where the menu data input comes from for the process of placing a pizza order. We also have a data store for inventory, as shown here on the screen. Again, placing pizza order as a process is one of multiple processes that is a part of a pizza ordering system. And so I'm quickly filling in the rest of this diagram. And don't worry, in our future videos that we have, we'll take a look at how to actually create a data flow diagram. But I wanted to fill this in just so you could get a sense as to what a more complete version of a data flow diagram looks like within the context of multiple high-level business processes. That is, placing pizza order, maintaining inventory, managing recipes, and making pizza. Now, this is what we call a level zero diagram. And a level zero diagram focuses on those highest level business processes that a system is meant to support. And so we have our inputs and outputs for those processes, including the actors, external entities, as well as the data stores that are involved with this. Now I'm going to draw a border around everything here except for the inputs and outputs for the actors that we have up here. And I'm going to shade this in because what we have inside this sort of gray, I guess, cloud, I know it's a terrible drawing, but it's the best I could do. But what we have in the gray is really all of those processes and, well, our data stores that are a part of this pizza ordering system. The actors are not part of a system, they're the originators of data and the ultimate destination for the information. And so I can represent all of these processes and data stores and data flows that are going on here as simply a pizza ordering system. Now, I've done some things in terms of the numbering. Don't worry too much about that for right now. But notice the inputs and outputs to and from our external entities remain the same. I haven't changed those, right? Just taking a look at customer, we can see order and receipt data flows. This is what we call a context level diagram. This is showing the inputs and outputs for the entire system. And this is more abstract. That is, there's less detail than what we had in our level 0 diagram, where we showed all of the high-level business processes as well as those actors or external entities. And so these are our 4 symbols for data flow diagramming. External entities, which I call actors. We have the process symbol, which always has a number associated with it. And it's not a number that's meant to be processed. The first process, the second process, they're not ordinal numbers, but rather they're simply meant to differentiate different processes. Same thing with data stores. We have a D and then a number to represent individual, distinct, discrete data stores, and then the data flow symbol. And that's it. These are the 4 symbols for data flow diagrams. Now, for the rules, a data flow between actors. Remember, business processes are the main star, the core of a data flow diagram. So we're not interested in data flows between actors, but rather we're interested in the inputs for a process of which data stores may be the source and the output from that process. And here I have an actor that is what we call a sink. Sink means the ultimate destination for information from a process or out of a system. And so, yes, that is acceptable in the rules of data flow diagramming. Showing an actor with data flow into a data store. Well, again, that's not the sort of thing we want to represent, or a data store with an output to an actor. Again, a business process is the main character in our data flow diagrams. Why is it the main character? Well, it's because the focus of data store diagrams are the inputs needed for a process and the information produced as a result of a process. In other words, a process transforms data. So to have the same data go back through a process as what was outputted from a process, well, it isn't technically incorrect, but it doesn't make a whole lot of sense. So typically, as a data store implies, that's just where data kind of rests. It hangs out. It's not transformed. The data that's stored in a data store is going to be used by another process, as I have represented here. And so that's the more correct way to actually use data stores within a data flow diagram. Now, there's another point which can be a little bit tricky, and that's the idea that a process produces information which would serve as data or input to an actor. And that actor does something with that data and creates new information. Let's kind of take a look at that same concept, but with a more specific example. So the process of, for a learning management system, uploading homework, having the completed student papers going to a teacher who then does something with that and grades the papers and has the output of graded papers. That doesn't actually quite work because, again, we're focused, we're interested. What we're trying to represent, what's abstracted here are the inputs and outputs for processes. That is, data being transformed. It doesn't matter who the actor is, but rather the process, the transformation. And if I want to be really technical, there's probably a data store here where those submitted papers hang out and then are used for the process of grading homework. Having data flows from one data store to another, well, that doesn't actually make sense. Data is at rest, so having data move between 2 points of rest really sort of implies it's just one single data store. If we have only input into a data store, that implies it's never seen again, so that's a no-no. Having only output from a data store, we need to show where that data came from, so that is also incorrect. Data stores, while they don't process data, they should include both an input and an output to them. And of course, we know input and then output from a process is what we're trying to focus on in our data flow diagrams. But how about a process that only has an output? Well, a process needs an input to create an output. So that would be what we call a data miracle, or only input into a process. Well, process does something with input to create output. So that would be what we call a black hole. That is, the data is never seen again, and we don't want that. So with that, folks, we wrap up our second video on data flow diagramming. Stay tuned for more.